All right, everybody, let's fill in some notes on graphing inequalities. So when it's written in slope-intercept form with instead of y equals mx plus b, we have some sort of inequality here. We are going to still first plot the y-intercept. Which of course is your b. And then you are going to use, from that point, you're going to use your slope, rise over run, to find the next point. And then you are going to connect them to make your line. But first you need to determine whether your line is going to be dotted or solid, because some points are going to be included and some are going to be excluded. So dotted lines are going to be if the inequality looks like either of those. Solid is going to be like this, greater than or equal to, less than or equal to. Similar to how this was an open circle and this was a closed circle when we solved inequalities. And then we also have a shaded region that we need to fill in, because an inequality gives us a range of values that is not limited to just a line. It's going to be limited to basically half of the graph. So we're going to shade the feasible region using the inequality. So if we have less than or equal to, that will be below the line, because less means below. And then if we have greater than or equal to, that would be above the line, because greater would be more or above. And the next thing that I say here is you can, and I would recommend it, testing a point in the inequality to check and see if your shading is correct. 0, 0 is a really easy one to test, which we're going to see in just a minute. So here's an example. So let's graph our y-intercept first. -3 right here down at the bottom. And then we are going to go from here. This is positive, so we're going to go up 1 and over 2 and make a point right there. Now, because of this inequality right here, this is going to be solid. So I'm going to connect that to be a solid line. And then we look at the fact that it is greater. So we're going to shade above, like this. So here's our next example. Plot your +1, and then use your slope to go down 2 and over 1. And our inequality right here is going to be dotted because it's a less than. So we're going to go like this and create a dotted line. Arrows on both ends. Now, because we have a less than, we're going to shade below the line. Okay, so we forgot to label what this region is. So basically what this is out here is called the feasible region. And it contains all solution points. So if I were to take, for example, this point right here, which is -2, 1, and plug it in here, I would get a true statement. So 1 is less than -2, plug in the -2, and then +1. So this is 4 + 1, and 1 is indeed less than 5. So this is true. And so this is the true region. Same thing when we go back to this one. Here's my feasible region. right, so now standard form is our other graphing, right? So to find the x-intercept, we plug in 0 for y and solve. Typically we get x equals at some point that goes on the x-axis. This should be already ringing a bell for you. Then we plug in 0 for the x and solve for y equals, and this goes on the y-axis. So this is also known as cover up and divide. So then we plot these 2 points on the x and y axis. So then last step is the same as the last with the slope-intercept form, is connect them, but we also still need to determine whether my line is solid or dotted. I think I wrote those backwards last time, so be careful. So less than or equal to, greater than or equal to would be solid. Same thing as a closed circle included. Less than, greater than, same thing as an open circle. So then what we have to do this time, so this is a have to. You can't use the inequality. Can't use the inequality to say above or below. So we want to test the 0, 0 point. If that point, once plugged into the inequality, is true, then we shade the side that contains this point, the true region. If that point is false, then we shade the other side, because you have a false side and a true side. So let's skip ahead to the first example, and we are going to follow these steps. So if I plug in a 0 for the x right here, then that is the cover up of the negative 2x. So I get 3y equals negative 6, and y would equal negative 2 when I divide. So I have a point right there on the negative 2. And then I have a 0 that I plug in for the y. That's covering up the y, the 3y. So I get negative 2x equals negative 6. Notice I'm using equal signs because I'm just trying to figure out what x value would give me that negative 6. So 3. So plot a point right there. So then we need to figure out, what is this telling me? Well, really, as is, the only thing it's telling me is that I have a dotted line. So I'm going to connect these with a dotted line. It does not tell me to shade above or below. I need to plug in my 0, 0 in order to decide that. So negative 2, I'm going to plug in, plus 3, plug in, and I'm really saying, is it greater than negative 6? And so let's plug in, let's see, and let's use blue this time. So I'm going to plug in a 0 and a 0. So the reason we like the 0, 0 is because really this is going to be 0 and this is going to be 0. So really this whole thing just goes away and I get 0. Is 0 greater than negative 6? That's true. So this point right here is true. So I'm going to shade all of this. Now some of you are probably saying, well, yeah, the greater than really is true this time. But what you're going to see in the next slide, next example, is that it's not always true. So do not use that inequality when you are using the cover up and divide method. All right, so option number 2, if you like saying greater than is above and less than is below, is you can convert your inequality into y equals mx plus b form. And then you can use greater than or equal to is above, less than or equal to is below. So here's the deal. Here's why, as a teacher, I don't really like this method. Be mindful of whether you multiply or divide by a negative. Because if this happens, you must flip the inequality. We learned about this when we solved inequalities, but we easily forget. And that's where students end up making mistakes in using this, because if you forget to flip, then you shade the wrong side and your answer is wrong. So example number 2, we're going to do in this method. So 3x minus 4y less than or equal to 12. So let's subtract the 3x over. So I have negative 4y less than or equal to negative 3x plus 12. And then I need to divide all parts by that negative 4. Y is, and this is going to flip, negative and a negative is a positive. So right here, this is going to flip to be like this. And these are going to make for a positive 3/4 x and then minus 3. So now I will go through all of my steps for graphing. So negative 3, and then I'm going to go up 3 and over 4. And I have a solid and above because it's greater than or equal to. So I'm going to connect this using a solid line, and I'm going to shade above. So if you notice right here, the 0, 0 should be true. So if I plug in a 0 here, and I plug in a 0 here, the whole thing becomes 0 is less than or equal to 12, which is true. So had I forgotten to flip, this, then I would have shaded below, which would be incorrect. So those of you that really love rearranging these equations, be mindful. And that's it. Have a good night.